Question 44. A punter kicks a football from a height of 2 feet with initial velocity of 82 feet per second at an angle of 63 degrees with the horizontal. Write parametric equations for the horizontal and vertical distances that the ball is from the punter after t seconds. So, from the formula sheet, we see that parametric equations for projectile motion are x equals the initial velocity times cosine theta times t, y equals negative 16t squared plus the initial velocity sine of theta t plus h0, the initial height. If you plug those values from the question into the equation, we see that 82 feet per second is the initial velocity, and 63 degrees is theta, and 2 feet is h sub 0. So our equations are x equals 82 cosine of 63 degrees, y equals negative 16t squared plus 82 sine of 63 degrees t plus 2. Part B. What is the position of the ball at t equals 5 seconds correct to 3 decimal places? Well, we need to put this in our calculator to get the answer. So if you turn your calculator on, go to mode, make sure you're in degree and parametrics, PAR. Go to y equals 82 cosine 63 close parentheses t, and y is negative 16t squared plus 82 sine of 63 t plus 2. Then you need to go to your window. T stands for time, so I don't know, let's start out with 0 to 5 seconds and make your t step like 0.1. X, we're going to start at 0. X is the distance from the punter. I have no idea, so let's assume that he kicks it 350 feet. I'll make the scale 50. The height of the ball. Y represents the height of the ball, so 0 would be the ground, and let's say it gets 150 feet high, and we'll make that 25. And then you hit graph, see if we have a good window. And it appears this is a pretty good window. And they want to know what it is at t equals 1.5 seconds. So, easiest way to do that is go to second table setup, put in 1.5, and then go to second table, and let's see what our answer is. Okay? So, 55, x equals 55.481 feet. We got that from the calculator. And then 75.549, that's the y value we got from the calculator. Part C, a player 6 feet tall, standing 50 yards, 100 feet from the punter, directly in the path of the kick. Will the ball go over his head? Why or why not? Once again, we use our calculator to obtain this. So we're going to scroll down until y equals 0, so 4.5. So go to second table setup. We'll start at 4.5, and we'll make this go by 0.5. Then go to second table, and you notice at 5 seconds. So second table setup. Let's go to like 4.9 and make this 0.1, and go to second table, and we're just going to scroll for a couple seconds, and we see that, let's see here, 150 feet away. I'm looking for 150. So, and they want 3 decimal places. So we'll go to second table setup, make this 0.001, second table. And we're looking for as close to 150, the x value, as possible. And we see at 4.029 feet, when t is 4.029, x is 149.99 feet, so it's up basically 150 from the punter, and it's 36 feet in the air, so it definitely goes over his head. So that's what you would write. So when the ball is 100 feet from the punter, t equals 4.029, the ball is at a height of 36.6 feet. Since the kick return is 6 feet tall, the ball goes over his head. Part D, suppose that the kick returner lets the ball hit the ground. When will the ball hit the ground correct to 3 decimal places, and how far from the punter will the ball hit the ground? Once again, we use the calculator, and now we're going to scroll, and we're looking for when is it going to hit the ground. So I'm looking for the last, or the first negative value, and still 5 feet above the ground. So let's see, let's get a little closer. 4.59. And you can see at 4.594 seconds, the ball has just hit the ground, and it's 171.02 feet from the punter. So that answer was obtained from the calculator.